Okay, great. Now we have a little helper function that not only returns us our images in the form of tensors, it processes the images for us, but it also returns the label so we can get it back in a tuple form. So let's utilize that to write another function that's going to turn our data, all of our data, because this only does one sample. We need a way to turn all of our data, so our X and Y, our data and labels, into batches of size 32. All right. Now we've got, let's write that down. Remember, we're trying to communicate to ourselves here in notebooks, a way to turn our data into tuples of tensors. And we go here in the form image label. Let's make a function to turn all of our data X and Y into batches. All right, wonderful. Now again, if you're wondering where all of this came from, a great place for any kind of data loading is to read through the documentation. I know it can be a bit boring sometimes, but trust me, reading through, even if you don't understand the first time, I didn't understand the first time, read through it, try it out again, and see how you go. This is going to be a big dog of a function. Oh, that's fitting because we're working on dog vision, but it's going to save us a hell of a lot of time later on. So let's do it. So we need to define the batch size. So 32 is a good start. Remember, TensorFlow defaults to 32 a lot. So if you don't set it somewhere, it'll probably default to 32, but we're going to define it anyway. So let's create a function to turn data into batches. And now we're going to write through this function together. And it's going to do a few little things differently depending on if we want a training data batch, a validation data batch, or a test data batch. Because remember, these are our three sets. There. So these are our three sets. So we've got a training set. We're going to turn it into a training batch, a validation batch, and a test batch. All right. So we want def create data batches. We want it to take in an X and a Y. And actually, Y can be none. Now, I want you to think about why Y might be none, because Y is our labels. This will probably make sense in a little bit. But just have a think about why might we want to create a data batch with no labels. Valid data equals false and test data equals false. And we'll leave ourselves a little doc string here. I used to have a colleague called Ron, and he told me a technique called rubber ducking. He was a lot better coder than I was. And he said, if you're having trouble figuring out how to do something in code, write it out in language first, or say it to yourself in language, as if you're talking to a rubber duck. And rubber ducks don't understand English very well, so you have to make it very clear. That's a great tip from Ron. Thank you, Ron. So this function creates batches of data out of image X and label Y pairs. It shuffles the data if it's training data, so mixes the data around, because if there was some inherent order into the training file that we downloaded, probably not, because these look pretty jumbled up. We don't want our model to remember that order. We want it to be as adaptable as possible, no matter what order an image comes in. But, so if it's training data, shuffle, but doesn't shuffle if it's validation data. Now, I want you to have a think about why it might not shuffle if it's validation data. Don't worry, we'll cover that, but just have a think about it for the meantime. Also accepts test data as input. Now, here is why Y might be none, because test data doesn't have labels, of course. Now, what we want to do is build a function that kind of does the same thing, but has some if clauses or elif clauses if it's valid data or test data. So we know what we kind of want to do. And we've got some conditions here that if it's valid or test data. So let's start off with the test data because I think that's the least amount of things. So if the data is a test data set, we probably don't, I was about to write definitely have labels, or we know we don't have labels if it's a test data set. So we'll go if test data, print, let's give ourselves a little heads up. I love giving myself a little heads up of what's going on. Creating test data batches just to make sure that later on, hey, maybe we're making some data batches and we've accidentally passed a false parameter to test data and it ends up doing it differently for the test data. We don't want that. We want to know that it's making test batches. So data equals tf.data.dataset. So this is the module in TensorFlow data. We're making essentially a batch data set. And we're gonna, this is a little interesting one here from tensor slices. So creates a data set, aka just a TensorFlow data set, whose elements are slices of the given tensors. So basically what this says is pass me some tensors and I'll create a data set out of that. A little confusing, I know, but this is just how it's done in TensorFlow. TF constant X. So basically what this says is I'm going to create a TensorFlow data set from the tensor slices, X, and because we're passing X to TF constant, it turns X into a tensor. So this is only file paths, no labels. Okay, and now data batch, here's where we turn our TensorFlow data set, because right now, this would turn all of X into a data set. We need to turn it into a batch size of 32. So equals data.map. We need to process the image. And we need to turn it into a batch size. Whoa, a lot of stuff going on here, Daniel. What's happening? Well, we've talked through the line above, but this one, all it's saying is basically take this data, which is a TensorFlow data set made of X, which is just file names in the form of tensors, and then map our process image function. See, this is why we made it into a function, so we can call it process image. It's going to go through all of these steps here on our file names. So it's going to import them, turn them into normalized tensors, and then turn it into a batch of batch size. Let's go here. So TensorFlow data batch. This is the workflow I use whenever I'm looking up a function. So if we go batch, there we go, batch, combines consecutive elements of this data set into batches. There we go. So if we pass it a range of 8 and we want it to be a batch of 3, it's going to split 8 into 3 batches. So that's just exactly, why is this in a new tab? That's what it's going to do here, except ours is of size 32. Wonderful. So that's the test data. Now we want to do, if the data is a valid data set, we don't need to shuffle it. Now I want you to think about, again, why would we not need to shuffle it? It's okay if you're not entirely sure. I got caught out on this a lot of times too. So we'll print a little progress statement here. And then we'll do much the same as this. We could just copy that, but we're going to practice writing it out. TF data dataset from tensor slices. Now, this is where, because our validation set has labels, we're going to pass it a tuple of X and TF constant Y. So just turning our file names and labels into tensors. And we got here file paths, labels. So now we have a TensorFlow data set of image file paths and labels because it's a validation data set. The validation data set has labels. And we're going to turn it into a data batch equals data.map, just the exact same as above, process the image and turn it into a batch of batch size. Oh, getting trigger happy. Wonderful. And then return data batch. And finally, we want, if none of these work, well, if valid data is false and test data is also false, it's obviously going to be a training batch. So we're going to go create training data batches. Boom, boom, boom. And let's go. So if it is a training data set, we want to shuffle it. That's the only difference here. So we want to go turn file paths and labels into tensors. So just as we done with the validation, we could just copy this. Now there's probably a more efficient way to write this function that does the same functionality, but I've tried to write it in a way that is fairly understandable as to what's going on. Constant X, and as I said that, I might have said that it's fairly understandable, but if you're coming across something like this for the first time, trust me, when I did, I was confused, but once I went through it step by step, remember our technique for breaking down a function, write it out line by line, and check out what it's doing at each line. So we want to shuffle the path names and labels before mapping. We'll go into this in a second. Before mapping, image processor function is faster than shuffling images. I'll just write the code so we can talk about it. But data shuffle buffer size. So buffer size just stands for how many variables do we want to shuffle, and we want to shuffle the whole lot. Whoa, a lot going on here. Well, all this is saying is, hey, take this data, which is a TensorFlow data set of the data, so the file names and the labels, and then shuffle it up. And we want to shuffle the number of examples. If we only shuffled 100, it would take the first 100 examples of X and Y and shuffle them. But no, we want to shuffle them all. And the reason being, you might see other tutorials shuffling later after we run the map function. Equals data map process image. So if you did shuffle after you've already processed the image, it takes a lot longer to shuffle a full image than it does just a file name. So as I said, remember, we're trying to minimize the time between experiments. So we want to try and get any speed ups that we can. I've just realized we've made a little mistake up here. In our validation data set, because we have images and labels, we need to map the function getImageLabel, which also processes our image. Whereas for our test data set, because we have no labels, we can run directly the processed image function. So let's replace this, getImageLabel, and it's going to be the same for our training data set. So getImageLabel, wonderful. And we might just write out what this is doing with a little comment. So create image label tuples. This also turns the image path into a pre-processed image. So if you can, shuffle your data when it's in its smallest format, aka, in our case, file names rather than full images. And now finally, we want to turn the training data into batches. So data batch equals data.batch batch size. And then we'll go out here, return data batch. Whew, that's a bit of a behemoth of a function, but as I said, this is going to save us a lot of time later on, and you'll see that. Remember, this is the kind of development work style I want you to start thinking about. Hey, am I going to reuse some functionality later on? Well, if I am, I'm going to write it into a function. And you probably already know that because you're a lot smarter developer than what I am. I used to just fluster around and just write things line by line. Now, let's test our function by creating training and validation data batches. So we'll go train data. We're going to use our big dog function just above. We're going to pass it xtrain for the training data and ytrain for the validation data. And that's all we need. And then for the val data, we could go create data batches, xval, yval, is it valid data, equals true. And now, fingers crossed, we should see our print progress messages. Oh, yes, that is amazing. Okay, now let's check out the different attributes of our data batches. So if we go train data, it's now in the format of a data batch, which is TensorFlow's preferred way of processing things. There we go. This is our training data, the first one here. What's it saying? So we've got shape none 224 2243. This is our image. None is for batch size. I know we've set it to 32, but it's going to stay as none because batch size, remember, is flexible. So this is just our images are now in batches of 32, and they've got a shape of 224 2243, height, width, color channels of type TF float 32. And we've got a tuple here of our label. So these are image label pairs in the form of tensors. And our labels also have a batch shape of none because batch size is flexible. And they have a dimension of 120, which is because if we go Y0, there's 120 different dog breeds. And then it's the same again for the validation data. Beautiful. So that was a pretty in-depth one. Once this video is over, which will be in a few seconds, I'd go back through and just read through what's going on in this function here. If you're not entirely sure, I'd look up loading and pre-processing data tutorial of images, have a read through that. And then the best way to learn is to really just write this out, break down the function, and try to run it line by line. That's how I break down things for myself. But the way our data is at the moment, it's still kind of hard to understand. If you're new to the concept of batches, it's probably a very difficult concept to grasp. It's perfectly okay not to know what's going on right now. So to help ourselves understand, rather than just having this gobbledygook being printed out when we're trying to check out what's in our data batches, let's write a function which is going to help us visualize what's going on. So that's what we'll do in the next video.